T-minus 1 minute and counting.
Status.
Range green. Stable at step 3.
T-minus 30 seconds and counting.
ECS reduced for launch. Roger.
25.
Status check. Go Atlas.
Go Centaur.
Go MUOS.
15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. RD-180 ignition and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the 4th Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Roll program is complete. SRB chamber pressures have plateaued. Mach 1. And booster has throttled back up, right on schedule. Engine response looks good. Pump speeds are good. Injector pressures are good as well. Max Q. Body rates look good. Engine has now achieved the proper throttle setting. Response looks good. And we have begun to throttle down. Engine response looks good as well. SRB chamber pressures looking good. Looking for burnout momentarily. And we have SRB burnout. And booster has now throttled to maintain a 2.5 G throttle in preparation for payload fairing jettison. Coming up on SRB jettison. And we've jettisoned 1, 2, and all 5 solids. Looks like a good separation. Now flying Q alpha limited steering. Vehicle rates look good. RD-180 continues to perform well. Closed loop steering has been enabled. Body rates continue to look good. Current altitude is 41 miles, downrange distance 58 miles, current velocity 4,992 miles per hour. RD-180 continues to perform well. Pump speeds, injector pressures look good. Body rates controlling right down the middle. Bus and battery voltages are good as well. And the RCS pyro valve has been fired. That system's now pressurizing to flight levels. Signatures look good. Booster continues its throttle to maintain 2.5 Gs in preparation for payload fairing jettison. Current altitude 67 miles, downrange distance 148 miles, current velocity 7,719 miles per hour. And we have payload fairing jettison. Looks like a clean jettison. And we have CFR jettison. Booster has throttled back up. Engine response looks good. All systems are nominal. Coming up on our 4.5 G throttle segment. And now throttling to maintain a 4.5 G throttle. Boost phase chill down is underway. Boost phase cool down is complete. And we have BECO, engine shutdown looks good. And we have retros and stage separation. Looks like a clean step. We have LOX and fuel pre-start on the RL-10. The GN2 purge firing on the RCS is underway. We have ignition and full thrust on the RL-10. Centaur steering has been enabled. Body rates look good. LO2 tank pressures have been vented down as expected. RL-10 performance looks good. PU has gone to closed loop control. Engine response looks good for that. Centaur is currently flying at 120 miles in altitude. Downrange distance is 595 miles. Current velocity is 13,827 miles per hour.
This is Atlas Mission Control at T plus 5 minutes 53 seconds. We've just heard Marty Malinowski confirm successful completion of the early phase of today's mission. All systems continue to operate nominally. The mission is currently in the first of 3 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in approximately 7 minutes. I'm now joined by Commander Paul Benishek from the Navy's Communications Satellite Program Office. Commander, thanks for joining me.
Thank you, Steve. It's a pleasure to be here.
Commander, what benefits does MUOS bring to the table?
Well, MUOS works like a smartphone network in space, vastly improving secure satellite communications for mobile users and the U.S. forces. MUOS provides users a global, on-demand, beyond line-of-sight capability to transmit and receive high-quality voice and mission data on an Internet Protocol-based system.
We're here for a satellite launch today, but I understand that there's much more to the system.
Absolutely. MUOS is a complex orchestra comprised of a 5-satellite constellation, 4 ground stations across the globe, an integrated waveform, radios, and complex software to manage the network. Additionally, more than 55,000 currently fielded radios and terminals can be upgraded to be MUOS capable, with many requiring just a software upgrade.
Commander, this is a Navy-led program, but only services can use this capability.
That's correct. The U.S. Navy plays a key role in national space efforts by providing narrowband satellite communications for the Department of Defense. While MUOS was designed for mobile users who require worldwide secure voice and mission data at higher data rates, these capabilities are also available for ships, aircraft, and ground vehicles used by all U.S. military services.
Commander, what kind of improvements can warfighters expect to experience?
That's a great question, Steve. So, the MUOS constellation will provide users with 10 times more communications capacity over the legacy system. You see, legacy satellite communication systems allowed users to talk as long as they were within the same satellite footprint. MUOS allows troops all over the world to talk, text, and share mission data seamlessly without having to worry about where they are in relation to a satellite.
Commander Benishek, thanks for all that great information. We'll continue our discussion after the next major milestone.
Engine performance continues to look very good. Chamber pressures, pump discharge, fuel venturi, all within expected regions. Tank pressures are stable. RCS lines continue to warm towards bottle temperatures. first burn is scheduled for approximately 464 seconds in duration. Range track shows Centaur making good progress right down the corridor. All Centaur systems continue to look very good. RL10 performance is nominal for the set MR. RCS line temperatures have nearly achieved bottle temperatures. Ullage pressures are stable. Helium bottle pressures look good. Batteries are good. Centaur continues to request an oxidizer-rich condition.
This is Atlas Mission Control at T plus 10 minutes 32 seconds into the MUOS-4 mission. All systems continue to operate as expected. The Atlas Centaur second stage and MUOS-4 satellite are currently located over the Atlantic Ocean, east of Antigua. Our next event, the first Centaur main engine cutoff, or MECO-1, is scheduled to take place in about 2 minutes. Here's Marty Malinowski.
Centaur continues to make good progress down the middle of the range corridor. Current altitude is 138 miles, downrange distance 2,075 miles, current velocity 16,942 miles per hour. Approximately 1 minute to MECO. And we have IIP vanished. Centaur is now orbital. RL10 continues to perform well. PU controlling near nominal. RCS line temperatures have achieved bottle temperatures. Tank pressures are stable. Batteries look good. And we have MECO. Engine shutdown looks good. We have 4S settling motors on.
This is Atlas Mission Control at T plus 12 minutes 38 seconds into the flight. The MUOS-4 mission is currently in a coast phase over the Atlantic Ocean, traveling in a southeasterly direction over the west coast of Africa. Our next event is the second start of the Centaur RL10 engine. This event is scheduled to take place in approximately 7 minutes. While we wait, let's take a look at a MUOS video.
MUOS, the Mobile User Objective System, is the U.S. military's answer to secure and reliable tactical communications for the foreseeable future, and it's being delivered by the United States Navy.
Now, 3 critical points for the MUOS program is first, it's operational, supporting the warfighter every day. Secondly, it brings enhanced capabilities over the legacy system. And thirdly, it is critical for the tactical warfighter.
MUOS is a global system, and it allows the communicator to make a call from, say, DC to the Middle East, all in one system. That capability is brand new, and with that capability, it brings a lot of opportunity.
Born from the need for stable 24/7 ship-to-shore communication that could be successful regardless of environmental and geographical conditions, the Navy is assigned the responsibility to provide this vast capability known as narrowband satellite communication.
So from a space accomplishment perspective, MUOS-1 was the highlight of our effort at the time. But fast forward to now, with the launch of MUOS-4, we are going to deliver that worldwide coverage and communication service for the users.
The nice thing about MUOS is that the ground system and the terminals contain all the switching and routing technology. The satellite remains unchanged over time, and we can allow technology insertion into the ground and the waveform over time to increase capability without having to make any satellite changes.
The MUOS WCDMA is similar to technology embedded in smartphones all over the world. It brings many benefits and improved capabilities over the legacy SATCOM system. It is already being demonstrated in various environments and for many purposes, like worldwide broadcast, extending SATCOM to individual soldiers, and communications above the Arctic.
The legacy payload we have on the MUOS satellites allow us that smooth transition to a newer, better MUOS capability. We are benefiting from that idea as we are providing the legacy channels for current user, and we are exploring all the capability that MUOS has to offer.
Users with MUOS terminals can seamlessly connect beyond line of sight around the globe. MUOS's new smartphone-like capabilities include simultaneous crystal clear voice and video mission data on a high-speed internet protocol-based system.
The IP-based nature of MUOS allows network access to unclassified and classified networks. This network access for deployed tactical users will allow the exchange of critical situational awareness and targeting information. As a naval pilot, MUOS will really bring that expanded communications chain, will allow us to coordinate with those forward air controllers, those tactical controllers that need air support at a much greater range. So there'll be less time over the target area. We'll be able to get there, provide the support, and leave.
With that smartphone comes the ability to introduce new applications, new ideas that haven't yet been envisioned by the warfighter. It's exciting to think about over the next 10 years how this system is going to actually be used versus how it was envisioned to be used by the original designers.
More than just satellites, MUOS is a complex DoD orchestra comprised of a 5-satellite constellation, 4 ground stations across the globe, an integrated waveform, the radios, and complex software to manage the network.
The mission of end-to-end integration is to bring together all of the systems that are required to deliver a MUOS capability to the warfighter. The MUOS program office was responsible for building the satellites and the ground systems and the software that programmed them, but other government program offices were responsible for delivering terminals and the teleport to connect MUOS into the global information grid.
MUOS's design allows it to extend UHF communications further north and south on the globe than ever before. This coverage into polar regions of the world is significant, considering wireless and satellite communications have always been a struggle at those latitudes.
For a whole host of reasons, the Arctic is becoming more important. So we'll be able to rely on communications here just like you were anywhere else in the world.
Warfighters need satellite communications on a variety of terminals: small, large, man-portable, and airborne. The key to this terminal implementation is the MUOS waveform.
The government makes that waveform available to any of our U.S. vendors who's building a product intended for use by the military. They take that waveform, they implement it on their product, and we assist them in providing laboratory facilities where they can complete their integration work. And the end result is more MUOS products that can put the desired capability into the hands of the warfighter that's suitable for their mission environment.
MUOS-4 is the 4th in the current constellation, and it will complete our global coverage for MUOS. And so The complete system for us is the 4 WCDMA payloads on orbit, the 4 ground stations, and 2 satellite control facilities. This is going to be really, really important in terms of providing beyond line of sight capability for our users. With MUOS-4 up and operational, we'll close the link and we will have coverage almost pole to pole and around the world.
Assuring current capability, developing next-generation communication technology, launching the future.
That rocket carrying MUOS-4 into space is like a giant flare, signaling to the users in the field that they're about to get an amazing new capability in their hands.
The Navy has and will continue to deliver mobile, tactical satellite communications to the Department of Defense.
Once operational, MUOS-4 will complete the MUOS network's near-global coverage, with MUOS-1, MUOS-2, and MUOS-3 satellites already on orbit. MUOS-5, an orbital spare satellite, is expected to launch in 2016.
Centaur LOX pre-start has begun. We have ignition and full thrust on the RL-10.
As Marty Malinowski just reported, the Centaur main engine has been restarted for the second of the 3 Centaur engine burns. This burn will last approximately 6 minutes. The Atlas V continues to travel in a southeasterly direction. Following our next event, MECO 2, or cutoff of the Centaur RL-10 engine, the Atlas V will cross over the African continent, continuing in a southeasterly direction over Madagascar, where the trajectory will switch to an easterly heading. Separation of the MUOS-4 satellite will occur over the Indian Ocean, south of Indonesia. As a reminder, separation takes place 2 hours, 53 minutes after liftoff. Our live coverage will end following our next event, MECO 2. Commander Benishek, it's great to have you back. Paul, can you give me a feeling for what kind of system testing has taken place so far?
Of course. So in our testing, we've tried to be as realistic as possible. So in several events, we've actually brought in uniformed warfighters, given them training on the MUOS system, and then allowed them to exercise those operations in a realistic environment, be that in vehicles driving around, in a forest with a thick canopy, or even in airborne platforms as well.
You mentioned previously the joint nature of the program. What work have you done with the other services?
We have great relationships with many of the other services and organizations like the Air Force, the Army, the Coast Guard, and Special Forces. We enjoy a great relationship with the Army as they prepare the Manpack radio for MUOS integration. The Army has been the primary user during our development test and operational testing from Fort Bragg, Fort Drum, and Fort Lewis. The Navy also works hand in hand with the Air Force. They provide invaluable transport and launch support and have demonstrated MUOS capability using C-17 in-flight mission demonstrations flying high above the Pacific Ocean. Also, Special Ops representatives have been key in helping us evaluate and refine our ConOps. And lastly, I also want to mention the great relationship we're developing with the U.S. Coast Guard. For example, the research icebreaker Healy demonstrated how robust MUOS is as it conducted Arctic research this summer.
It seems like things are changing pretty quickly and all for the better.
Yes, it's a pretty exciting time with that smartphone-like capability because it comes with the ability to introduce new applications and new ideas that haven't yet been envisioned by the warfighter. It's exciting to think about over the next few years how this system is going to actually be used versus how it was envisioned to be used by the original designers.
Thanks, Commander. It's now time to get back to the mission.
RL-10 continues to look good. Chamber pressure, LOX pump discharge, fuel venturi, all within expected operating parameters. Tank pressures are good. Batteries look good. To use controlling at nominal MR. Approximately 2 minutes left in this burn. All systems continue to look very good. Fuel tank pressure levels are increasing as expected for this point in the mission.
This is Atlas Mission Control at T plus 25 minutes 20 seconds into the flight. We're a minute or so away from the completion of the second of the Centaur main engine burns. Let's go back to Marty Malinowski for the final call-out of the morning.
And PU has been commanded to fixed angles in preparation for MECO. And we have MECO. Engine shutdown looks good. We have 4S settling motors on. Fuel tank pressures are being vented down. Storage bottle pressures look good. Batteries are good as well.
This is Atlas Mission Control at T plus 26 minutes 39 seconds into flight. 2 of the 3 planned Centaur RL-10 engine burns have occurred, and the mission is now in an extended coast phase, with all systems continuing to operate as expected. After completing a 2-hour, 23-minute coast period, the Centaur main engine will be restarted for a short third burn, followed by a short coast period. MUOS-4 delivery on orbit is scheduled to occur at 2 hours 53 minutes. Due to the long duration of the flight, we'll now conclude our live coverage. Commander, thanks for being here.
Steve, my pleasure. So as you can see, this is another important milestone in the MUOS program. So go MUOS!
Okay. I'd like to thank Marty Malinowski for his support of today's show, and for more information on the Atlas V, please visit our website at ulalaunch.com or join the conversation on Twitter or Facebook. We'll complete our live coverage with another look at today's launch, which occurred at 6:18 a.m. Eastern Time. I'm Steve Agate, and on behalf of the entire ULA launch team, have a great day. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. RD-180 ignition, and liftoff. Liftoff of the United Launch Alliance Atlas V rocket carrying the 4th Mobile User Objective System mission for the United States Navy. MUOS significantly enhances communications for U.S. forces on the move. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Roll program is complete. SRB chamber.